Okay, so from yesterday, this is question C. And remember how to find the inverse. We need to let the function equal to y. 3x, x minus 1. And in this case, x can't be 1, because if you get 1 minus 1, you get 0 in the denominator, which means there's no function at that point. It doesn't exist at that point. So they always put some condition. And in this case, x can't be 1. Let's make it a bit bigger. Okay. So now the next step is to swap the x and y. So we'll have x equal 3y, y minus 1. And then we cross multiply x, y minus 1 equal 3y. And then we need to expand this out. So we'll get xy minus x equals 3y. You have two y's here. So the problem there is that you need to group these together. So we'll put them together, and it doesn't matter where you move. So what I would do, I'd probably bring my 3y over to here. So I'll have xy minus 3y, and then I'll stick the minus x on this side to give x. Okay, and now I've grouped the y together. So I'll take a common factor, which is y, x minus 3, okay, equals x. So now you can see I can divide both sides by x minus 3. Like that, and this one will cancel. So basically the x minus 3 goes down there. So your answer is y equals x on x minus 3. And that's your inverse. F inverse x is x on x minus 3. So that's your solution. If you did your rearranging differently, you'll get a slightly different answer here, but it's actually the same graph. So you may get two possible answers for these kinds of questions, but it's actually the same answer. But that doesn't matter. I'll mark them both correct anyway. That depends on what you move down here and how you move things around. Let's look at the solution for D and see if you get it correct. Okay, so we always start by letting the function equal y. X minus 3 on 2x plus 1. We swap the x and y in all positions. So the y will become x and the x becomes y. So y minus 3, 2y plus 1. Okay, so now we will cross multiply to get your 2y plus 1 up on this side. So x 2y plus 1 equals y minus 3. So it looks like we need to expand this because we have a bracket. So 2xy plus x equals y minus 3. Now we tried to group the y's on the same side here. So let's put them on over on the left side. So 2xy minus y equals minus x minus 3. At this point, we will factorize out the y. You'll get 2x minus 1 equals minus x minus 3. Okay, and now the simple thing to do now is just divide by 2x minus 1, both sides. They're all done the same way, every question. Just a little bit of variation in the method. So then we'll get y equal minus x minus 3 on 2x minus 1. Your answer may look a bit different than this one. It depends on how you've moved these numbers down here. So this is your inverse. So minus x minus 3, 2x minus 1. But like I said, your inverse function may look different than that. But if I graph them, I may find it's actually the same. So don't worry if you got something slightly different than that. The signs may be different, that's all. So that's your inverse function there, okay, for that one. So take note, because you'll need to know about this in maybe 5 or 10 minutes. Let's look at these two. So I'm going to test your knowledge. So take a look at this one. Now you've got a quadratic. Now this is here for a reason. I'll teach more about this next week. So this graph is only when x is greater than or equal to -3. There's a reason for this, which I'll explain next week. But we can still find the inverse anyway. So we let y equal x squared plus 6x plus 3. Now, before I start swapping x and y, what I want to try and do is get this to be a complete square, because I don't want to have y squared and y. It's going to get really messy. So what you do, we complete square. All right, so we have x squared plus 6x. Now, half of 6 is 2, and we square that. We'll get 9. So this 9 needs to be added here and subtracted from here. So we'll have plus 9 minus 9 plus 3. You see what I did there? I put plus 9 minus 9, which is 0, isn't it? So these are actually still equal. These equations are equal. But I did that, so now I can complete the square here. So y will be equal to x plus the square root of 9 is 3, all squared. Okay, and minus 9 plus 3, that's minus 6. So do you see what I did here? I took the middle number, which is 6. What you do, you halve that number, so divide by 2 and then square it, you get 9. And then stick that number back in here, which is highlighted blue. And you have to add 9, then subtract it, because you can't change the equation. You're not allowed to. So I did that. So now I only have 1x, not 2. So now I swap my x and y. Okay, so you're going to get x equals y plus 3 squared minus 6. Okay, so now how are you going to rearrange this? You want y equals, yeah? So we've got a minus 6, so stick that on the other side. So I'm going to get y plus 3 all squared is x plus 6. Okay, and now I need to square root both sides. This is back to grade 9. And this will be plus or minus. Whenever you take a square root, you need a plus or minus sign here, because, for example, square root 9, it can be 3 squared, or it can be minus 3 squared. Okay, so 3 and minus 3. So be careful with this. This is back to grade 9 quadratics, okay? So you've got plus or minus here. And we'll see in core, we may have more time to talk about this in core, I hope. So then what you do, just cancel your square. So y plus 3 is plus or minus square root x plus 6. Okay, and then we'll bring the 3 to the other side. So y is minus 3 plus or minus square root x plus 6. So I'll leave this one here for a little while for you to copy down, because this is a common kind of question. And I think you're going to see this in your worksheet when you get inverse function worksheet. All right. Now this has 2 signs. So at the moment, well, what I'll tell you, this actually only has one answer. So it's going to be minus 3 plus. There's a reason for dropping that sign, and I'll talk about it next week. But if you get to this stage, this is okay. x plus 6. Now, x must be greater than or equal to minus 6. Because if the number's not, you'll get a negative number here. So this is our condition. So your answer is here. This is your inverse function. So I've gone all the way across to the other question. So we'll rub that out in a minute. So this is your answer here for your inverse for that one.